So, a couple weeks ago, an article came to my attention and stuck with me so much that I decided to start a YouTube channel about it. The article was published in this website called Science Feedback, and it is titled, "What is Peer Review? Why one peer-reviewed Grok written paper doesn't disprove climate change." Let me read the first few paragraphs of the article. When is a scientific paper not a quality scientific paper? On the 21st of March 2025, a paper emerged claiming that humans aren't responsible for climate change. One of the paper's authors, Jonathan Kohler, claimed on X that it was the first ever peer-reviewed climate science paper. Curiously, the paper credits the AI large language model Grok 3 as its lead author. The paper quickly gained traction online. Robert Malone, a well-known source of vaccine-related misinformation, shared it in a blog post that has garnered more than 1 million views. A 25 March 2025 article from the website Slate News called it the first ever artificial intelligence-led peer-reviewed climate science paper and stated that it has confirmed that climate change is a hoax. This idea is incorrect. The paper hasn't confirmed anything. There's overwhelming evidence that human activity is changing the climate, far outweighing papers like this one. Below, we show why this paper is incredible. We'll start by talking about how peer review works. So someone wrote a paper using Grok because that's where we are now, which all that means is they fed it a bunch of prompts and got the outcome that they wanted to, presumably. I don't really know. But the paper was published on a website whose stated purpose was, according to the article I'm referencing, to publish scientific contributions which contradict the very often unilateral climate hypothesis of the IPCC, and thus to open the view to alternate interpretations of climate change. This suggests that the website's true purpose is to only publish papers supporting a particular conclusion, in other words, that it's openly biased. So that is all kinds of ridiculous. The purpose of this video is not to engage with this specific paper, this specific Grok written paper. I don't really think there's any value to that, and I'm sure other people, including this article, have done a better job at it than I could ever do. The article on Science Feedback that kind of alerted me to this continues on to talk about what peer review is, how journals do peer review, and what good peer review is versus what bad peer review is, etc. And that's really what I want to talk about today. I've seen a lot of discussion sort of related to this and maybe independent of this about peer review and maybe academia in general on social media, YouTube, the internet in general, that have kind of been talking about this topic from people that I'm not sure understand it very well, and that's what kind of prompted me to try and at least explain it a little bit and make a video about it. I don't know if this is new or if I've just been out of the loop long enough, but I've gotten the impression lately that a lot of people who aren't scientists have a fundamental misunderstanding of what peer review publications are, how they work, what they do and what they don't do, what are they sort of expected of them and what it isn't expected of them. So I just wanted to give my my 2 cents on the topic. So let's dive in. Let's talk about peer review. So unless you've directly dealt with this, there's a good chance you don't really know how peer review works and how scientific publication works in general. So let me present a rough step-by-step guide of what sort of like a journal article goes through before and after it is published or during the publication process. So you do your research, you've written your grant. I mean, I guess that there's that step, and there's actually peer review there, but I'm not talking about that. I'm talking about purely about publications. So this just occurred to me, but that's a separate topic that we can maybe talk about another day. But you write your grant, you have your money, you have your students who will do most of the work, and you do the research, and the research was successful by whatever metric it is that you're measuring it, and then you write up a paper. This is not a linear process. Sometimes it goes back and forth. Sometimes the research yields more than one paper. There's collaborators and all that, but you have a paper at the end of it. You have a paper with a research methodology and conclusion, and then you identify a journal to submit it to. This is primarily based on subject matter, so the specific discipline and some discipline, multiple journals in the same field can have different, maybe the way they are specialized or things that they like to publish versus what they don't like to publish. So you know, if you've been in a field long enough, you'll know what journal fits your research the most. So you identify it based on that. There's also, I think, a small amount of prestige. So generally, scientists want to publish in the more prestigious the journal, the better. And how prestige is measured, what prestige means exactly in scientific publication, is a bit controversial. So I don't really want to delve into that. But it really just something that can affect your selection of journal. But I think the subject matter is far more crucial. That so I've identified the journal that you want to submit to. You look up the submission guidelines. This can be anything from formatting, like what file formats they expect, how they expect the paper to be organized, even things like how many citations you're allowed to have, etc. You look up whether there's a fee associated with publication. In general, if the paper is going to be open access, that means it's going to be available to the public for free. There is a fee associated with publications. If it's not open access, it's usually free, although that can vary wildly between uh, journals and fields. And I think sometimes there are grant or institutional requirements on whether a paper needs to be open access or not. But that's hopefully you have enough money from the grant to pay the fee if a fee is required. And then you submit to a journal. You format it the right way. You've done all the work, and you submit it. You hope that it's going to be well received. And at first, an editor looks at it, and they make the initial decision on whether to send the journal for peer review or to reject it right away. And right away acceptance it is not an option here. It's either rejection or it will be sent to peer review. At least if it's a reputable journal that does it the right way. If you know what you're doing, you'll rarely get a desk rejection. Almost certainly, you would at least get to the peer review stage. But it can happen. I guess if you've submitted to the wrong journal and the editor doesn't think the paper is right for the journal, but they can recommend a different journal, etc. So we get to the main point. We get to the peer review. The editor sends your paper to your peers. And what those are usually other scientists, professor, and postdocs. It's rarely graduate student. In fact, I don't know of any case where peer review is sent to graduate student, but sometimes you get cases where the professor just pawns off the work to a grad student. So that happens. But it's usually people who are very knowledgeable on the subject matter of the research that the paper present. The reviewer's job is to check for a few things. Now this can vary, and I think the inconsistencies may be part of the point that I'm going to talk about in a little bit. But in general, as far as my experience is the among the things that the reviewers check for is first, well, is the paper appropriate for the journal? Is it novel enough for the journal? Because that's where the prestige enters for. And is it original enough for publication? Generally, you don't, journals, again, this may depend on the field, but if you're just doing something that someone else has already done, it's usually that's not valuable. Again, depending on the journals. And then after that has been established, then the reviewer's job is to maximize the quality or to ensure that papers of the maximum possible quality are published. And if the quality is not good enough, then the reviewers don't recommend the paper for publication. And if it is good enough, they do recommend it. More often than not, it's somewhere in the middle where the reviewer offers critiques, suggestions. They may have questions. They may have um, requests for you to do more work, and maybe resubmit it, or it can be any combination of the above. So these reviews, there are a few sort of variations in the way that they can happen. These reviews can be fully open, meaning that both the reviewer and the author knows who each other are. They can be double blind, so that's the opposite of that, where the author doesn't know who the reviewers are and the reviewers don't know who the author is. Both of these situations are very rare. The most common situation that I've seen is where it's single blind. So the reviewers are anonymous, but the authors of the paper are known to the reviewer. And based on their judgment, the reviewers, like I mentioned, can give an outright rejections with or without comments. It's very rare to get a rejection without comments, but sometimes you can get comments that are maybe not very helpful. You can get an outright acceptance with or without comments, but again, it's very rare to get something back with absolutely no comments. And the most common is where you get an acceptance uh, with conditions that require either minor or major modifications. And I mean, I use the word acceptance. This is not really an acceptance, but this could be just a suggestion that the reviewer says something along the lines that this cannot be accepted unless the author does XYZ things more than what they've already presented. And this, the comments of the reviewer get back to the author, and the author, depending on what the comments were, has the option to reply back with either doing the things that the reviewers requested, or maybe answering their questions and clarifying things that the reviewer may have not understood. And this can go back and forth. This can be a very short process, and it can be a very long, drawn process. So again, inconsistency is one of the themes here. There's not one glove, one size fits all. It can be wildly different, and so like I said, this can go back and forth until the paper that is either accepted or the reviewers and the author kind of reach an impasse, and that usually means rejection. Of course, the editor can intervene here. The editor can sort of like veto the reviewers. Maybe the reviewers have a problem with the publication, but the editor, after the authors have submitted their comments, the editor can intervene and say, well, I think the authors made a good case. I'm just going to veto you and accept this paper anyway. I don't know how common that is, but it certainly happens. So generally, the peer review process is not open. So people who haven't done this directly may not have access to it. But there is, I think, a growing trend of open peer review, and then some journals do publish their peer review with the permission of all the parties involved. So it might be helpful to have an example of that. And the one journal that I know that does this, I'm sure it's more than one, but it's the PLOS journal. So this is an example of an article that was published, last year or something, a computational model for bacteriophage VX174 gene expression. And if you go, this is the article, you can read it. I think PLOS is exclusively open access, so you can read it for free. And you can even leave comments. I don't think many people do. But you can go to the peer review tab and look at the peer review process. So for this specific paper, we see that the paper was submitted September 9th of 2024. There was a decision letter that, if we click on it, actually contains the peer review as well. So if I read the beginning of the decision letter, it says, "Dear Dr. Wilke," that's the corresponding author, "thank you for submitting your manuscript PLOS One. After careful consideration, we feel that it has merit, but it does not fully meet PLOS One's publication criteria as it currently stands. Therefore, we invite you to submit a revised version of the manuscript that addresses the points raised during the review process." So this is a very, very, very typical answer of what you get. It's, the work has merit, but you need to address this. And then if you scroll down, we see the instructions on how to do this. And then if you scroll further down, you see the comments from the author, and this is specifically the reviewers, and I believe there are two reviewers. And we see the comments from reviewer one, and they have specific questions, and sometimes they do line by line comments on the paper. And in your response, you have to address all of the for the paper to be reconsidered, you have to address all of the reviewers' comments, questions, suggestions, whatever it is. And we see here that these authors have done that. So they, in October 14th, so a few weeks, I think, after they got the response, they formulated their own response. And after that, it appears that we're pleased to inform you that the manuscript has been judged scientifically suitable for publication, and will be formally accepted for publication once it meets outstanding technical requirements, which are usually trivial. And I've never published in the journal, and this is not my field, but it is very typical of what a peer review process looks like. So if you want an example, maybe look more into that journal to see how it is. So this is, I think, a pretty good representative of what peer review looks like, at least in the general case. And if you want more examples, you're welcome to browse the paper and look at other interactions there. Sometimes it can be quite interesting, but mostly it's just boring. It's just other scientists who have a problem and they want answers, or they just they have legitimate concerns with the publications, and it's essentially a form of correspondence with the author to ensure the maximum quality before publication. So it is reasonable to expect that when peer review works correctly, we get papers that are relevant, free of errors, innovative, and overall advance our scientific knowledge. So it's generally a very healthy way to do science in the modern world. The article that I referenced earlier on science feedback makes the case that not all peer review is created equal. Reputable journals do peer review the right way, while less than reputable journals don't do peer review properly. And to quote one expert that they interview, if I go to the article, many so-called predatory publishers state that they do peer review, but it is impossible from the outside to judge the quality of peer review. I've had journals run spell checks and call that peer review. Just saying that peer review happens doesn't mean that actual peers critically reviewed the paper. Basically, just because a journal says they do peer review doesn't really mean that they do peer review properly or at all. And there are many journals that have been labeled as predatory or pay to play, pay to publish, whatever, to then whose peer review practice are either non-existent or totally abhorrent and insufficient to publish good science. In this video, I don't want to dwell on bad peer review, because bad peer review is just bad. It doesn't. There's nothing to talk about it. It's when a journal is not interested in publishing real science and has a bias, that's a very simple case. What I want to focus on is the peer review process when done properly and what that means. And before I delve into it, I just want to make it clear that this is not a peer review exposed kind of video, or academia exposed, or all these kind of things that you often see on YouTube or other social media from so-called public intellectuals with questionable motives. Peer review is an extremely valuable tool in the way we do science today, and that is kind of the starting point where my position is. But I do want to contextualize it from people that are not very familiar with it or don't deal with it on a regular basis, and explain what it does and what it doesn't do. I think a lot of people who are not scientists, and that can either be lay people or even people who interact with science and scientists, like science journalists, science communicators, science enthusiasts, advocates, policymakers, etc., have this view, have this perspective that peer review is the sort of like absolute infallible mark of quality. And I don't think that quite aligns with how scientists uh, view peer review, which is a little bit more complicated and nuanced. I don't think I've ever met a scientist who, at one point or another, hasn't been extremely frustrated with a peer review process of one paper or another that they've tried to publish. And of course, there might be a little bit confirmation bias there, because usually if you have a problem, you're more likely to complain. If things are going great, nobody's ever going to hear from you. Obviously, people have had bad experiences, and that's undeniable. Still, I think a lot of scientists view peer review as kind of doing taxes. It's annoying when you're doing it, but you kind of, when you step back and look at the big picture, you kind of understand that it's necessary. Then again, you do sometimes wonder where your taxes go, whether they're used correctly and whether they're used efficiently. And at the same time, I think it is important to understand that peer review is not a flawless process. and to have a better idea of what it does well and maybe what it doesn't do so well. So the effectiveness of peer review is an active area of investigation that it is actually growing. And like I said, like the example that I showed, open peer review is one example of that. But as a result of the deeper look into peer review, there are naturally criticisms that have risen. And I want to mention some of them. First, I want to look at criticisms that have been posed about peer review that I don't think are at all or entirely attributed to peer review, that they're often caused by something else. So the first one that you'll often hear is about the reproducibility crisis in academia, that we have a reproducibility crisis, and that what really that means is people often can reproduce results that they read in paper. Now, this is a complicated issue, and I don't want to go into details about how much there is or there isn't into this matter, but the one thing that I think it must be said about it is that it is very field specific. You often, I think, see it on social sciences more than in natural science, but of course you also it's also talked about in biomedical science. But on the one hand, like this is something that these particular sciences where this is perceived to be a problem have taken steps to address this. But the other thing is, I don't think this is really related to peer review. And I think that's because of kind of the second point, because these two are related. The other criticism of peer review is that it is not able to, or has not been very successful in detecting data fraud, data manipulation, and things like that. And this is a tricky one because, for one, it is related to sort of like the perceived reproducibility crisis, and it's also something that people think peer review should be able to catch, right? Like why do people review your work? But I personally think that's a somewhat unrealistic expectation. Like after all, if the peer reviewers can't really repeat your experiment, if you just outright lie and make up data, like that's until someone repeats your experiment and tries to replicate it, there's just no way they will be able to find that. So I don't think that's what really peer review should be doing in the first place. Now, I've seen suggestions of that peer review should be looking at the raw data more carefully, but then again, unless there is a statistical anomaly, which can happen, and sometimes that's how fake data have been found, but unless that is the case, unless the peer reviewer specifically like replicates your experiment, that's just not going to happen. And with the amount of science actually happening today, that is an unrealistic expectation. So I think peer review should look at the sort of like the impact of the study, the importance, the soundness of the methods, the soundness of the statistics, the methodology, etc. But I don't think it should be expected to sort of like determine if you've completely fabricated your data. So I think that's a completely unrealistic expectation. Another criticism that I've often seen is sort of like the oversaturation of papers. Again, I don't see what that has to do with the peer review process. I think that is entirely a consequence of just the fact that we are just doing more science. I think some of these problems can perhaps be raised on the whole of academia. There is something that is often described as publish or perish, which is sort of the pressures that a lot of people in academia have to publish and kind of churn out papers above all else. And that is something that maybe should be looked at. But again, I don't think it has anything to do with peer review. And on that topic, it's like you have to understand that how much science has changed from 100 years or even 50 years or even like 30 years ago. There's so much more science happening. There's a lot more scientists. There's a lot more competition for places. So a lot of these things that perhaps when there was, in any given field, there was maybe 10 people doing that, any maybe issues are going to be kept under, they're not going to be easy to surface. And as more people flood into a certain thing and do it, a lot of the issues that are inherent with anything that people ever get involved with, then obviously those issues are going to surface. and knowing those things and studying those things, we can address them. But that doesn't mean there's anything inherently wrong with the actual practice. Is just when a lot of people get together and try to do stuff, and successfully for the most part, obviously issues are going to arise, and that is true of academia as well. There's also another, going back to peer review, there's also another category of criticism that I would maybe label as of the more philosophical variety. One criticism that I've seen is that peer review encourages the homogenization of academic writing and makes it overall less accessible to the general public, or just less accessible in general. And I think that's kind of nonsense. I mean, scientific writing will never be accessible. That's the goal of science communication. You cannot expect a like a paper, a scientific paper, a journal article to be accessible to anyone but the people that work in that field, especially since science becomes more and more advanced, and it kind of adopts its own jargon and its own kind of language. That just not going to happen, and it has nothing to do with peer review. The other thing that you often see associated with peer review in academia in general, that peer review suppresses big ideas and big papers in favor of mediocrity, because it's sort of designed to avoid controversy, and therefore it is suppressing the next Einstein or Newton or whatever name there in any field. And you often see these discussions together or in associations with, oh, we haven't had a major breakthrough in X number of years and whatnot. And like I kind of hinted, I see this a lot from people in three categories in general: crackpots who are just mad at the establishment because that's really the nature of crackpottery. Another category, which is related but I think distinct, is bad faith actors peddling nonsense, who, again, it would be a lot more easier for them to peddle nonsense if there was a bias towards the establishment, which in this case is academia and peer review. And I think I don't want to discount people who don't belong to any of these two categories, that have genuine concern about, is peer reviewed, like in any way kind of suppressing any big ideas. And I think, even though the concern may be genuine, I think it does show a fundamental misunderstanding of how science works today, and possibly how science has always worked. I mean, progress is done in very, very small incremental steps. I mean, it's unlikely that there's someone out there with a paper that is going to replace quantum mechanics, and the establishment is keeping them from publishing, and that just not going to happen. If I can use an analogy, and I have no idea if this is a good analogy, but it's like the only one I can think of, is kind of like playing Mortal Kombat or any other fighting game. I think they all kind of work the same, where you kind of fighting different enemies at different levels, and the early ones are easy, so you can kind of pull off all kinds of amazing combos, and you can get away with it because just like they're weaker, they're slower, they give you time. But as you progress and you fight enemies that are more and more advanced, you're lucky if you can just spam the same move all the time. You don't have time for all those like complicated combos and moves. And I think science is kind of like that. The more we advance, the harder it becomes, and the smaller or the rarer the apparent breakthroughs are, because we have very successful theories and very successful advancements that are kind of pretty solid, and it's kind of become harder and harder for them to be toppled. Even considering the past, I do wonder, not being an expert in the history of science, I do wonder if it hasn't always worked or this, because we kind of, by the way history works, we kind of remember the big things, but there were other things happening at the same time. There's a sort of historical genius washing happening, that we forget the small contribution and we'll remember the giant leaps, because we kind of like to have heroes in our narratives, and that's kind of how we're wired, I guess. But if you really think about it, in the grand staircase of scientific progress, there's a lot of tiny steps that are kind of smoothed out by history, So the leaps appear bigger than they really are because we just remember them that way. We think Isaac Newton invented calculus out of thin air, but he really didn't. And I think that's kind of important to remember when we kind of think about these things. And even then, controversial science gets published all the time. Fringe theories get published all the time. It's not, as long as it's not complete crack pottery and it is based on some kind of solid foundations, like these will get published. In a way, peer review is sort of a gatekeeper, but it's more of a moderator than a gatekeeper. Like if, if you using physics as an example, if the math makes sense, you'll even if it contradicts any known theory, you'll get it published. It's not that hard. Maybe you won't get in Nature, but Nature being the one of the top journals, but you'll get it published. And there are like specific examples of this happening. In addition to you seeing all kind of fringe theories being published all the time, there's also uh, successful theories that at one point were controversial and then eventually get being accepted into the mainstream. And one example is that of Dan Shechtman and the discovery of quasicrystals. Dan Shechtman is a material scientist. I believe that would be the most apt description. And he is credited for the discovery of quasicrystals, which he did, I believe, on a sabbatical at Johns Hopkins University. I think he's from Israel originally. I don't remember the institution that he works at. I'll put it here. And just to give a brief explanation, crystals are order materials that have translational symmetry. That means that they are repeated in space in all 3D coordinates. And for that to happen, there are only a certain amount of rotational symmetries that the individual unit cells can have. And though, for example, five-fold symmetry is not allowed because you can show that then is it five? I think it's five-fold symmetry. But you can show that you cannot have a translationally symmetric system if you have certain forbidden symmetries. And quasicrystals are systems that break this rule. They are ordered systems, but they're not periodic in the X, Y, and Z dimension, but they do exhibit these forbidden rotational symmetries. And Dan Shechtman made the discovery, I believe, in 1982, so not that long ago. I guess it was about 40 years ago now, but considering it kind of completely shifted, completely toppled a well-established paradigm in material science and crystallography, it was a fairly recent discovery. And there was a lot of pushback from the scientific community. It's still this. I think still the discovery progressed normally. Was in fact at the same time there were theoretical papers that had shown that this was indeed possible, unlike it had been previously speculated. And yes, scientists pushed back. One of the primary scientists who did push back was the chemistry Nobel laureate Linus Pauling, who believed Shechtman had made a mistake and what he had observed were not quasicrystals, but it was, you know, something else, I guess. And because of the big name, he gained some traction. But I believe eventually the scientific community, relatively quickly, I believe in the space of 2 to 3 years, had sort of started to accept the idea that quasicrystal existed, and that was a possible form of material that existed. And I think the most tragic aspect of this story is a lot of the personal insults that Shechtman endure. I believe there were people who encouraged him to quit his job because he was saying something that was impossible, and there were people who were mailing him basic textbooks because he was claiming that something existed that was so fundamentally wrong according to the established paradigm of crystallography. But he didn't have trouble publishing it eventually. And while yes, I think the personal attacks are never acceptable, and like I said, I think that's the most tragic part of the story. I think the pushback is arguably a good thing. I think something that is going to topple a very long established paradigm should receive the strictest scrutiny. And it did, quasi-crystal did receive the strictest scrutiny, but I think science eventually won out, and his discovery became widely accepted, and then he won the Nobel Prize in 2011. So this is, I think, an example of science working as intended on something controversial, and more specifically, peer review working as intended. So what are some legitimate criticism of peer review? And there are a few. One of them is that peer reviewers are not paid, and this is bad not only because it's unpaid labor, but it's also, you could argue that the reviewers don't necessarily have a great incentive for doing a good job or doing the peer review at all. And of course, there are examples where scientists just refuse to do peer review. They are often kept confidential. Journals don't make, in general, journals don't make peer review public. So that means that for people who are investigating this and they are trying to analyze them and determine where peer review works and where it doesn't work and where we could be improved, don't necessarily have the data to do these kind of analysis. But this is sort of changes. Peer review can take too long. And yes, this is indeed true. They're not double blind. They're usually single blind. Some people have argued that double blind is not necessarily desirable, although I don't really know. In small fields, it wouldn't really work because you can usually know who wrote. Like if you're a reviewer and you have knowledge of a field, you can look at a paper and immediately know whose group it is. It is responsible. It's a relatively small world out there. One thing that is kind of big deal in my opinion is kind of a sort of an inconsistency. There are poor and inconsistent instructions often given to reviewers, and this is again can vary between fields, journals, and even sort of like individual reviewers. I've heard stories of every possible scenario. I've heard cases where the peer review was too lenient, too strict, peer review where the editor intervened, peer reviews would have had one person only, and peer reviews where there's 5 people doing the peer review. So again, this inconsistency is maybe I think one of the biggest crutches of peer review. One possible case that can be made is that journals are run like business, and there are nonprofit journals or journals based on associations or nonprofit associations. And there are also for-profit journals, but I would argue that all journals are kind of run like businesses, and they have to survive. And maybe that's something that we have to rethink. And one of the biggest criticisms that I've seen of peer review is that it can be biased. And of course, it kind of makes sense, right? You are a person, and there's a possibility that a competitor is reviewing your work. I'm not sure about this one. I think a lot of the evidence and the stories are anecdotal. I mean, there's definitely bias, of course. Like I mentioned earlier, any human endeavor that's ever existed in science or outside will have bias, right? Anytime a group of people do something and they're asked to judge each other's works, there will be bias. And there are, like I said, steps that people are taking to try to mitigate this bias. But I'm not sure that it is happening to an extent that it is so detrimental that scientific progress is not made. Again, this is more a personal observation. Like I said, I'm not sure what the data, if any, available says on this topic. But the one thing to keep in mind is bias will always exist, and we should try to mitigate it. We should do what we can, but established scientists will get preferential treatment. Newer researchers will always have to work harder to prove themselves regardless of merit. There's a lot of work that we can do and we should do to minimize these biases, but we will never completely get rid of them. I think one area where we can maybe do a lot of we can put a lot of effort is sort of like address these biases when they happen across gender or ethnicity or nationality and things like that. So I think that's a problem that it is addressable, and we should be doing work to address it. But of course, we will never completely eliminate bias in general. It might be helpful to show these through some examples. I don't want to use any real papers that have been published or papers that have maybe retracted to show kind of how peer review works. So I'm going to make up some scenarios, and maybe they'll be helpful. So let's see. So these are completely make up examples, but I think they're good representatives of what could happen or what would happen. So let's say you have a study. Someone is trying to publish a paper of mice solving mazes. I don't know. And they found that when mice are given American cheese versus Swiss cheese, they solve the maze faster. I don't know. It's a silly example. I'm not a biologist. Give me a break. So they publish, they submit this, and the reviewer looks at it, and they love it. They say, oh, this looks good. Maybe they have some suggestions. That's fine. And the paper passes through peer review and gets published. So sometime later, if other scientists are interested in this, they will maybe try to replicate. They'll look into it deeper. Maybe they'll try to do variations of the experiment, and they find that they cannot really reproduce this. So what really happened there? Well, it's possible the experiment is just hard to reproduce. This happens all the time. It's possible that there are variables that the initial authors did not identify, or maybe they couldn't control, and they didn't do a great job at communicating. So it's possible that those variables are contributing to the results in a way that it was not foreseeable. I guess maybe a genuine mistake. It's also possible that the authors fake their data. So did peer review fail here? Like I said, I don't think so, because I don't think this is a case where the reviewers were expected to know. They saw the data, they saw the statistical analysis, they judged the methodology, they determined that it was an interesting study, they determined the methodology to be sound, but the raw data was wrong. I don't know. Maybe I don't know. I guess I don't know enough about these kind of experiments. So maybe there was some red flags that they could have identified. I'm just, in this hypothetical scenario, there were no red flags. So let's just consider that. So like I said, I think science worked as intended here, and then the scientific community found this interesting. They wanted to do more, and that's how it kind of self-corrected itself. And like I said, there are plenty of legitimate reasons why this experiment might not be reproducible without the scientists being involved in fraud. Mistakes happen. Like I said, science is complicated. A second example, let's consider a paper from some chemists who wanted to do some simulations to understand the mechanism of reactions. They use a simulation method, which usually involves approximations, to try to understand what the mechanism of a given chemical reaction is. And so they write a paper, they submit it, the reviewer looks at it, and he does not think the method that the authors have used is appropriate for this kind of reaction. He says, oh, I know a lot about this method. This is not a good approximation. You should do something else. You should use another one, or maybe he'll say you need to verify, or you need to convince me that this is good enough for this particular case. The authors can do the calculations again, but those take time, resources. Maybe they don't really have the time to do them, and maybe they're convinced that the method they've used is good enough. They can say, we've done some tests, and they can maybe present those values, or they can say we've read a lot of other papers, and they all use the same method for similar reactions, so we're convinced, we're pretty sure that this is good enough for what we're doing. And then the reviewer can sort of maybe they can say that fine, I don't agree, but that's you can still publish as long as you maybe add something to say that to emphasize the approximate nature of the calculations. Let's just put it like that. Or the reviewer can be stubborn, and insists that no, I know this method very well. You will not convince me. I know that this is not good enough. You have to do it in a different way. And that's kind of an impasse. Now, the editor can intervene. Maybe the editor is convinced by the argument that the authors have made, and the editor can intervene and say, that's fine, I'll veto the reviewer, the paper gets published. Or the editor does nothing, and eventually the paper doesn't get published. The authors can submit to a different journal, so it's not the end of that. But as far as the paper in this particular journal it was not published. And in my opinion, this paper should be published, because the authors have clearly stated what they've done. There's nothing, they stated what the method was and what the results were, so anybody can verify that or use their own, make their own judgment about whether the method that they used is accurate accurate enough. So I think the reviewer here is maybe being a little bit too strict. Although again, like it's like maybe the reviewer is truly an expert in that method and he has information that most people don't. And usually they'll try to back this up with publications or maybe can try to convince the author why they think they're wrong, or sometimes they can just say no, and that's the end of the story. So I think this is a trickier example, something that shows how inconsistent this can be, because maybe there were two other reviewers who had no problem with it, but this one reviewer had a problem with it. It can be time because this can be a back and forth that can take a long time. And of course, if the authors decide to read, maybe do the extra calculations that the reviewer demanded, then it's then that's extra time, extra resources that I have to spend on this study. And it's also possible bias. Maybe the reviewer is being dishonest. Maybe he's working on the same thing and he's just trying to delay it. Again, I think this is rare, but it's definitely something that has happened and can happen. And that's the I hope these like kind of made it clear about what can go wrong during the peer review. But I think one common theme in all my readings about this topic is that we simply don't have enough data on this idea of examining sort of like the efficacy of peer review publication is a relatively new thing. And I saw this paper, this article from 2020, I believe, that kind of raises all the possible questions that we might have of peer review and proposes the establishment of a new field, that of peer review studies, to investigate these things more precisely rather than relying on a lot of anecdotal evidence, which is kind of what we do because we don't really have a good understanding of how science has been impacted overall by these inconsistencies, and whether they are a big deal or if they're just more of a nuisance. And I mean, if you look around, there's been some really great science and technology that's kind of happening around us, and maybe you could argue we could be doing even better, but you certainly can't argue with the results, unlike what you often see people on YouTube or TikTok or is Snapchat still a thing? So definitely there's something working right. It's not entirely wrong. And that's why I'm kind of tired of comments that I've often see when this topic is discussed, sort of like the system is broken type of comments, speaking of academia and peer review specifically, uh, from people who either don't understand this or they clearly have an agenda. Uh, and I'm doing my best here not to be specific because I don't really want to talk about any particular instance or people. Just want to make it as general as possible. But what I want to add is that even if you don't belong to this category of people and you have legitimate criticism, which, like I said, there are legitimate criticisms that can be had about this topic, statements like, oh, academia sucks or peer review is broken, all that, I mean, they're kind of reductive. They kind of ignore the nuance and the complexity that these issues represent and that these systems represent. And they also don't really offer any steps forward because, like I said, a lot of it is working right, but there are things that we could do to improve. So, without counting bad faith actors and conspiracy theorists or whatever, people, there are legitimate criticism to be raised, and I think raising them in a nuance and in a way that acknowledges the complexity of the situation is the best way to address them. One of big big uh, big complaints that I see is of peer review acting as a gatekeeper, which I already kind of mentioned, in favor of something that is entirely open or a lot less restrictive. And while I do understand the sentiment, I'm very skeptical. There are examples of harmful gatekeeping in science, especially when it comes to women and minorities, but I don't think that's what these people are talking about. I there is a negative connotation to the word gatekeeping that I would argue is without merit in this particular case. And I think personally, I don't trust any community to self-moderate, to self-regulate, even a community of scientists. Uh, and if this is even more important when you consider that we don't just communicate with between scientists, we also communicate with the outside world, with science journalists, communicators, policymakers, politicians, etc. So it's very important to have some kind of moderation, some kind of maybe filtration that kind of prevents the things to go completely haywire. I mean, we've seen what happens to unmoderated communities on the internet, and I'm not sure that science without any kind of moderation is what we really want, although I'm not an expert. Going back to the issue of peer review, there are things that have either been suggested, proposed, or are currently being tested as a way to improve things. One is open peer review, which I showed an example of this. At the very least, this will make the process open for analysis and further study. Preprint publications before peer review as a way to quickly disseminate information before the actual formal process of peer review happens. I think journals can make a lot of effort to provide better instructions for the process of peer review, so eliminate some of that inconsistency, at least on a per field basis. It would be nice. There could be a sort of a feedback look for the reviewers, so the reviewers, maybe there is a way to provide feedback for when the reviewers that do a good job versus the ones that don't do good so much, although that's kind of hard to implement when reviewers do this for free and it's essentially unpaid labor. I've seen suggestions for multi-stage peer review, which is kind of interesting. It's kind of the kind of thing I kind of want to read more about, where there's a first stage where authors submit a proposal essential to the journal saying this is what we plan to do. So without having the data, or at least maybe somewhere in the middle of a process, but before they have the final paper, and the journal sort of like peer reviews that or investigates that in some way, and then commits to publishing the study, the paper, once it's finished, regardless of how it looks like. So I mean that's an interesting idea. Obviously, I think that probably the details are more involved than what I already mentioned, and it's something that I might want to read more about. There's obviously more research and studies that are kind of happening in that regard. And then one thing that could happen is to compensate reviewers. Maybe if we didn't rely on unpaid labor, the process would be overall better. Maybe compensate them monetarily might be a little bit unrealistic. I don't know if that's even anybody will touch that, but it could be they could be compensated in other ways. We can make the process of peer review maybe more valuable to a scientist's career. We can sort of incentivize them through career advancement in that hand, because right now it's kind of more of considered as a charity, like you kind of have to do it because others do it for you. So it's kind of this quid pro quo idea. And I think incentivizing through career advancement might be another way. There could also be kind of a credit system with journals that they could do, because as I mentioned, more journals are kind of moving to this open access model, and that it's usually associated with the fee. So there could be an approach where if you decide to do peer review for journals, maybe you get a discount on the fee, or maybe even free credits for publications in that specific journal or journals by the same company or association. So that's something I think could be that could be a system that the journals implement very easily, and like it would be better than nothing, right? I guess I don't know. A part of me worries that none of this will happen, and the journals will just kind of lump all their hopes into AI if some haven't done already. I'm hoping that it won't happen because scientists will be up in arms, but we're not the revolutionary kind, so I don't really know. Some of these issues are maybe larger in academia than specifically with publishing and peer review. There's the publish or perish mentality, in which scientists are incentivized to publish papers above all else. Now, again, that's not necessarily a bad thing. Just because you have to publish papers to kind of advance in your career does not mean that the quality of the research you do is going to be bad, but it definitely can raise questions to some people. It can maybe increase the bloat of academic publishing. Like, if I am incentivized to publish more paper, and one experiment that could be published as a single paper, if I can stretch into 2 or 3 papers, I will do that. So like that maybe oversaturates the field a little bit, and it can be like a source of pressure for academics. I remember one physics professor in college telling the class one time that he wished he could just take 6 months to think about the problem instead of having to kind of write a paper in those 6 months. Although if you have tenure, I guess you could do that, but surely that will impact your if you don't publish in a while. I think granting bodies will probably see that with a raised eyebrow a little bit. Even I seen a quote from Peter Higgs, the Nobel laureate, uh, famous for the Higgs boson, uh, complaining about something similar in an interview that he gave to the Guardian. He says, quoting the Guardian here, he doubts a similar breakthrough could be achieved in today's academic culture because of the expectation on academics to collaborate and keep churning out papers. He said, it's difficult to imagine how I would ever have enough peace and quiet in the present sort of climate to do what I did in 1964. He kind of has a point. I'm not sure I agree entirely. Peter Higgs was sort of like not a prolific publisher, and I think he also like didn't publish anything for a couple of years before his 1964 paper or pair of papers that he did. But we call it the Higgs boson, but he wasn't the only one working on this. There were, I think, 6 other people, a group of 2 scientists from Belgium, and then a group of 3 from the UK, and they all published the papers on the same topic in 1964 at the same time as Higgs, or around the same time, all arriving at that independently. And there are also other scientists who published just a little bit later, so they didn't get there as quickly, but very likely they also arrived on it independently, or they were working on it. And all of these were a lot more prolific than Peter Higgs. So, perhaps some scientists would benefit from this kind of reduced pressure, but there's absolutely nothing to suggest that having to publish paper or publishing a lot of papers diminishes the progress that you can make scientifically. So I'm like, that's why I say I'm not entirely sure that I agree with Peter Higgs. And of course, you have to remember 1964, science has changed a lot since then. There's a lot more scientists now, and there's a lot more competition. So the pressure to publish can be a little bit of an annoyance, but I don't know of a better way when there's money involved, when there's grants involved, when there's competition involved. I don't know of a better way to objectively measure like a success, or the way that you've kind of done what you were paid to do, other than peer review publication. So maybe there is a way, if there is studies in this area that can kind of come up with alternatives, that certainly I would be welcome to hear them. I want to finish by going back to the original article that I mentioned in the beginning of this video, the one from Science Feedback, where their conclusion is that, or at least their main thesis is that, one peer-reviewed paper does not disprove climate change. And I just want to generalize that by saying that one peer-reviewed paper doesn't prove or disprove anything. And while their argument is specifically in context of bad peer review, I'll maybe extend that to all peer-reviewed publications. So perhaps maybe remember this as a TLDR of the video. Peer review is an extremely valuable tool in scientific publishing, and unless someone suggests something else, it's currently the best way we know how to do science. And I don't think that's changing anytime soon. But it's not an infallible process. To put it in mathematical terms, peer review is a necessary but not sufficient condition for correctness, and I think people should keep that in mind. My message to everyone that engages with scientific uh, context online outside of peer review publication: we'll never get rid of clickbait or titles that portray things in dishonest ways. But when you read something about science, like, oh, chocolate may prevent cancer or whatever, first of all, ask yourself, is this based on a peer review publication? And if it is based on peer review publication, but it's only 1 or 2 papers, then just remember that 1 or 2 papers doesn't really prove or disprove anything. It's interesting. Maybe keep that in mind. Maybe you decide to follow it up, but just remember 1 paper doesn't really prove anything. And I think that's really all I had to say on this topic. I hope it was valuable. And if you have any comments or questions or suggestions, feel free to comment below. Otherwise, I will see you next time, maybe.